All right, so today we're going to talk about a new kind of loop. The new kind of loop is a for loop. When do you use a while loop or a do while loop? When you want stuff to run over and over again. So why do we need another kind of loop? All right, for loops usually won't run forever. You can mess them up and make them infinite if you really try. All right, so a for loop, traditionally we use a for loop when we know exactly how many times we want something to run. So if we want something to run exactly 500 times, you would usually use a for loop. Could you use a while loop? Correct. You could use a while loop. You would need something to count, and you would need to increment it inside your loop, and when you count it up to 500, you would tell your loop, stop running. Okay? So, the way a for loop works. Oh, so anything we can do with a while loop, we can do with a for loop, and vice versa. Anything you can do with a for loop, you can do with a while loop. They are interchangeable. So a for loop is just another option that you can use. The notation you have for loops is you're going to have the word for, and then you're going to have a parenthesis. Counter variable equals initial value. So you're going to have a starting value here. So you'll have a variable name, like count, maybe. Count will equal 0. You'll start at 0, perhaps. Semicolon. And then you'll have a test condition here. So count less than or equal to 500, perhaps. And then a semicolon. And then your increment counter here. So the advantage of the for loop is everything that involves your looping control is right at the top, right at the beginning. So with a while loop, it's easy to forget sometimes to put in the count plus plus down at the bottom of your while loop. Or it's easy to forget to say read the next value in, and you end up building an infinite loop. With a for loop, that very rarely happens, because everything that controls your loop is right here, right at the top, and you can see it all in one spot. And you've got to put all three things in. Now, so notice that there's a semicolon here, a semicolon there, but no semicolon at the end here. What happens if you put a semicolon at the end there? It ends the loop. And I see people doing that in the lab with while loops still. All right, so I see people writing while, repeat equals yes. And I see people putting a semicolon right there. What does that do? It ends the while loop, so whatever comes next, it's not going to do. Actually, whatever comes next, it will do, always. It'll do it once, only though, it'll run the next. So whatever you have in this set of curly brackets, it's going to run it, but it's only going to run it once. When do you put a semicolon at the end of a while statement? When it's part of a do. So if you have do, and then you have a bunch of commands, and the while comes at the end, then you should have a semicolon there. And I've also seen some people doing that with if statements. They're putting if, and then at the end of this round bracket here, they're putting a semicolon. You shouldn't have a semicolon there either. All right, but anyway. So you're going to have for your initial value, a semicolon, test condition, semicolon, increment counter. A very common mistake that I make, and I make it a lot, is I put commas in between here. And the reason I think I put commas in between there is I've done a lot of programming in a different language called BASIC, and BASIC uses commas in between. So watch out for that. If you put commas in between, it's not going to work. And that's a mistake that I make, and I make it all the time. It bothers me. All right, so anyway, we're going to have for, and then we're going to have our conditions. And then just like every other thing we've done, we'll put a curly bracket, we'll have a bunch of statements, we'll have a curly bracket to end it. So, some typical examples. For I equals 1, semicolon, I less than or equal to 10, semicolon, I plus plus. How many times would that loop run? 9? 10? Anybody want to vote for 11 as long as we're going 9, 10, 11? It'll run 10 times? Why 10? Because it has less than or equal to, so it's going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, equal to 10. That loop will run exactly 10 times. 4, total equals 0. So there's our increment. There's our initial condition. We start total at 0. Total is less than the maximum, so it doesn't always have to be an equal to. Total equals total plus sum. How many times will that loop run? Correct. We do not know. We do not know how many times this one will run. This one will run until total is less than maximum, and total is total plus sum each time this loop runs. So it's very similar to a while loop. Very often when we use a while loop, we don't know exactly how many times that while loop is going to run. That can happen in a for loop also. You might have a for loop when you don't know how many times it's going to run. It depends on the code. 4, x equals 50, semicolon, x is greater than 5, x equals x minus 5. How many times will that one run? 9? Sounded a little reluctant. It was? Well, it's going to start at 50, right? And it'll run when it's 50. And then each time it's going to subtract 5, so it'll run there. It'll run there. 2530. 2520. Keeps going. 1510. 5. But it does not run for this one, does it? So it's going to run 1, 2, 3, 4, 5, 6, 7, 8, 9 times. That's correct. It will run exactly 9 times. All right. We saw the continue statement and the break statements for while loops. They also work for for loops. So you might have a test, and you might choose to continue. If you choose to continue, what's that going to do? It's going to run the loop again. So from the continue, it's going to go back up to the loop. It will increment the counter and keep running. So it's going to skip, as soon as it hits this continue, it's going to skip running its current loop, its current status. It'll go back to the beginning of the loop, increment the counter, and then move on and run again. Why might you want to do that?
When you have like a mathematical integer program, when you want to go back to that instead of just doing calculations again later on in the program.
Okay, so you have a function. For some reason, this number that you're trying to plug in is no good for that function, but you don't want to stop doing the rest of your choices. So you just skip doing the function that one time. Let's say, for example, you had something where you ended up dividing by 0. You wouldn't want to divide by the 0 because the computer would burst into flames, and that would be bad. So you skip it, but you go on and you try the next one, and maybe the next one you don't have division by 0, and it's okay. So you keep running. And then why might you want to have a break statement? Well, the break statement would do what? If this were not continue, if this were the word break right here, what would it do? It would completely end the loop. So maybe if you end up with a division by 0, maybe the first time that happens, you want to be done, and so you jump out of the loop altogether. Different options there. All right, so example. Let's write a program that will read in exactly 500 values and add only the positive ones. All right, so let me get this set here so kind of see. Switch it. All right, so how am I going to write a program that will read exactly 500 values but add only the positive ones? So we're probably going to read them from a file. You don't want to type in 500 values from the keyboard? That sounds like a wonderful idea. So we're going to include. I can type in 500 if I want to. Kill the rest of the class time. Be done for the right? Sounds like a good idea. And then, so I included fstream so I can read from the file. What's the command to tell it to read from a file? Ifstream. Read, or whatever name you want to call it. Parenthesis. File name in quotes. Our file name, I guess, is going to be data.txt, is what I heard. Comma. iOS. Colon. In, because this is an input file. Alright, so there's our if string. Okay. So we want to read in exactly 500 values, but add only the positive ones. So how do I do that? What kind of variables am I going to need? I'm going to need a number for reading in the values. And I'm going to need a total. All right. It didn't tell me if these were integers, so I'm going to assume they're not. So I'm going to go with floats. Float, number, and total. All right. What else do I need? I need a variable in the for loop, just as some sort of counter to count up to 500, right? That should be an integer. Absolutely, it should be an integer because we want to count exactly to 500. All right, so there's two options. I can do an int count right here, or I'll show you the other option that you could do. So I'm going to need a for loop to run 500 times, correct? So for. Where do I want counter to start? We want count to start at 1. Semicolon. When do I want count to end? Count less than or equal to 500. I prefer to do the less than or equal to 500 instead of just equal to 500. And the reason I do that is just in case I messed up and I made count to be a float variable. And then sometimes floats, you get little decimal portions, round off, errors every now and then. So I like to do less than or equal to 500 because sometimes it won't exactly hit 500 if I use a float and I get tiny little round off error. As long as I use an integer for count, I should be okay, but I'm going to do less than or equal to anyway. And then another semicolon, count, plus plus. All right. Close bracket. So I was going to show you there's two options. Option number one is we can do exactly what we did. We can put int count right here. The other option is you can take that out and you can actually define the variable right there within the if loop, within the for loop itself. So you can do for int count equals 1. So you can define the variable and initialize it right there in the for loop if you want to also. Either one will work. Whichever method you prefer. I kind of prefer doing it right here because then I don't feel like I need to document it. It's obvious that I'm using this as a counter in my for loop. So I prefer to put it right there. All right, then what? Read the first number. All right, so read number. All right, I read the first number. If number is greater than 0, total plus equals number, else continue. Okay. Anything else I need? Could what? I would probably put my output out here, outside the loop. The total is total. If I put it inside the loop, then it's going to print it each and every time, and I don't think I want a running total. Do I need the else continue? No, I don't. God told me to put it there, so I put it there. How come I don't need the else continue? It's not really going to do anything, is it? Because
It's already at the end of it.
it's already at the end of everything we want to do. Because if the number is positive, it increments the total. Otherwise, I just want it to go and read the next number. So no, that else continue really isn't doing anything.
Well, somewhat lost is what
This program will read 500 values and add only the positive ones. That's what it's supposed to do. So what's it going to do with the negative ones? Just ignore them. So I really don't need that else continue, so I might as well take that out. All right, well, I have two problems at this point. One, I wasn't prepared. I don't have a data file that contains 500 values, so I can't run this and try it. Two, I could make one real quick.
It doesn't have to be 500.
Well, it would actually have to be 500 or more, because this loop is going to try to read 500 times.
So what happens to your condition?
What happens if your data file only has 100 values and it tries to read 500 of them?
It's going to keep trying to count zero.
More likely, it'll read in garbage. It'll make up numbers for you. Probably not E. It's more likely to give you things like 1.2 times 10 to the negative 11 and things like that. If it can't find data, it usually makes it up for you.
Can you do a condition inside of it so you count it either 500 or to the end of the file?
All right, so I could have in here an if I reach the end of the file, do a break. And that way it would read 500 at most, but if it had less, it would break. That would certainly work. Okay. So do that. So if read dot end of file break. All right. Oh, I have an extra right parenthesis there. So now I can make a tiny little text file and we can try it here, see if it works. It's not going to work. It's going to crash. There's a mistake. And will tell me what the mistake is. No, the second if is okay. Is the issue in line 20? No, it is not. Well, yes and no. When this program gets to line 20, that's where it's going to crash, but that's not really where the issue is. The problem is I did not initialize total. I should initialize total. That's where the error really was. All right, so let's make a quick little text file. I could, but it might not be in a text file format. I'll just make one real quick. So give me some nice numbers. 5.
42.
1. What was yours? 42. Negative 17. Let's just make sure it skips some negative numbers. And 7. All right, that's enough because we want to be able to add them up, right?
-3.
-3. That's not going to change anything. All right. So let's see. 42 plus 7 is 49, plus 1 is 50, plus 5 is 55. It should add up to 55. Now, I need to save this, and since I don't have my memory stick plugged in, I need to save it in the right spot, so I go to Documents, Visual Studio 2017, Projects, console application 1, console application, and we're calling this data.txt.
So you have to say that in console applications to read the data.
Yeah, well, I either have to save it on a memory stick and then tell it to look for E:/ or F:/ whatever my memory stick location is, or I need to save it in that directory where I just saved it. My program is called console application 1, so it needs to go in that directory called console application 1, unfortunately. A little hard to find. All right, let's see if it worked. Thinking. Control is 55. Did we get the right answer? Yes, we did. It probably would have been nice, since it didn't read all 500, to give a message about how many it actually read. We don't have to keep track of count. It's already being kept track for us. So we might have a cout. There were count values.
But it's based
All right, so his question was, isn't count only defined in the for loop? Yes, and that's the disadvantage of putting the int count right there. This int count, this variable, only exists inside these curly brackets. It does not exist out here, and that's why this is giving me an error right here. But we can fix that, right? We should just be able to put int count right here, and then take that int out there. Well, it wouldn't compile and it wouldn't run. You know, it had the little red line of death there, which told me the program wasn't going to compile. So that's the disadvantage of putting the int count within this for loop definition. If you need to use that later on for something, it's not going to exist.
So if you had multiple for loops, or if you had two variables that were named the same thing, but one of them is defined inside the for loop, one of them is defined outside of it, they could run in completely parallel, not interacting with each other.
And that's bad in a way. That's poor programming when you have two variables with the same name. But yes, you can do that. And I think we're going to see an example of that in just a minute. All right, let's try this again. There were 6 values. Is that right? Were there 6? 1, 2, 3, 4, 5, 6. Can't have that. So notice it gave us a total of how many there were altogether. It didn't tell us how many positive ones there were. But I guess that's okay. All right. So we did that. All right, how often do the following loops execute? Assume X is not changed in the loop body. All right, well, the first one I think we already did. X starts at 1, X less than or equal to 10, X plus plus. How many times will that run? 10. We already answered that question. That was on the previous page. How about this one? X starts at 0, X is less than 10, X plus plus. Still 10. That's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 this time, but that's still 10 if you count it out. I think we already answered this one. X equals 50, X is greater than 5, X equals X minus 5. That one we ran 9 times. X equals 10, X is greater than 0, X minus minus. 10. because it'll count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's 10 times, I believe. X starts at negative 10, x less than or equal to 10, x plus plus. 20. Anybody want to vote for 21? You want to vote for 21?
22.
22? Do I hear 23? No, it's not enough. Why do you say 21? All right, so let's count them out. It goes negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and then back up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then it goes back up 10 more. So that one actually runs 21 times. And that's a trap that people forget. People forget about 0 happening one extra time there. So this one will actually run 21 times, not 20. Even though the distance from negative 10 to 10 is 20, it runs 21 times because it runs for 0 also. So watch out for that if you're using positives and negatives. That's a sneaky one. How about if I start at negative 10 and I end at 10, but I go by 2s? Well, let's see. It's going to start here, and it's going to go 1, 2, 3, 4, 5, 6, and then back up, right? 7, 8, 9, 10, 11. That one will run 11 times. Again, the 0 causes issues there. This one will run 11 times. How about if I start at negative 10, end at positive 10, and I go by 3s? Six, 7, infinite loop. I heard infinite loop. Well, let's see. It's going to start here. This will be 1. Then I'll add 3, so there's 2. Add 3 more, there's 3. Add 3 more, that's negative 1. How many was that? 4? 1, 2, 3, 4. And then going back up, when I add 3, it's going to be at 2. So that's 5, 6, 7. The next time it adds 3, it gets to 11. 11 would be too big. But somebody did bring up a good point right here. If I had 4, x equals negative 10, x equals 10, x equals x plus 3, that would be an infinite loop, wouldn't it? See, I told you I'd make that mistake. You're absolutely right. Those are semicolons. See, that's easy to fix when you write it by hand. You see just the dots again. So this one we said would run 7. Is that what we said? 7? 7. This one would be an infinite loop.
That's why you would be less than.
And that's why I like putting the less than. Just in case I make a mistake like that and it creates an infinite loop. That's why I like putting the less than in there. It saves me from infinite loop mistakes. Questions on that? All right, so this is related to John's question a minute ago here. Notice that I have int x defined here, and then I have another int x defined there. I have the same variable used twice. Is this code legal? Yes or no? And if so, what will it display on the screen? So the guess is, yes, it's legal. Why is it legal? I have one inside the loop and one outside the loop. This x only lives inside those curly brackets, where this x apparently is within the whole void main somewhere, and it's a global variable. So this actually is valid code, but it's not good code. It's very poor code to have the same variable used twice, same variable name. What will it print? So let's see. Int x. X goes from 0 to 10, x plus plus. Int x again. X goes from 0 to less than 10, x plus plus. C out X. C out, what's that do? That's equivalent to an end line, isn't it? We haven't seen that in a while. So what's it going to print? Just 10?
But it's the loop goes, isn't it? Oh, the one that
So the question is, when it gets to this C out statement, which X is it printing?
the one in the loop.
It should print the one that's in the loop. It should be printing this one. So what's it going to print? Going to print 9? It's going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9?
It's still in the loop.
Correct. If there's only one statement, I don't need the curly brackets, but this would be the same. It's only one statement for that for loop, so I didn't really need the curly brackets. So, this X is going to start at 0. Then this X is going to start at 0. And it's going to see out that 0, isn't it? And then this loop is going to repeat. So it prints the 1, and this loop's going to repeat. It prints the 2. So this is going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When it gets to 10, it jumps out of this loop, and then what's it do? There's a new line. So it comes down to here. The end line's within which code?
What do you do again?
Yeah, what did 0 and the next one, 2.
All right, so
Because it's within.
if
No, I see it. I see the inside.
so if I right there, that C out is indented. So if I have a for loop and I don't put a curly bracket there, it's only going to run the very next line. So that's why I wrote this curly brackets in there to indicate that this C out is not in that inner for loop. It's outside of the inner for loop. Outside of the inner. That's a weird statement. All right. So anyway, this X starts at 0. This one prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we do a new line. And then we go back to this loop now, don't we? And now this loop is 1. It's going to put out the same thing again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it will do that 9 times. So there'll be a total of 9 lines here. So that code will actually work, but it's poor code. It's poor code for several reasons. One, we still don't use single letter variable names, correct? And we don't use the same variable name twice. That's a really bad idea. But it is valid. It will actually work. All right, how about this one? Rewrite the following for loop into a while loop. So we have int I, int s equals 0, for I equals 1, I less than or equal to 10, I plus plus, s equals s plus I. So how would we take that same code and write it as a while loop? I would need to start with int I equals 1. I would need to initialize I at the beginning. I still need that. Int s equals 0. While I is less than or equal to 10. Curly bracket. S equals S plus I. I'll leave it exactly the same way as it's written there. And then I plus plus anything from my I. So, there it is as a for loop. There it is as a while loop. So you can see the difference. The difference is, for the for loop, we increment within the loop itself. For the while loop, we have to increment outside the loop. We have our test condition, that's the same. And then with the for loop, we increment within the command of the for loop. In the while loop, you got to remember to increment later in the while loop. All right. How about this one? For m equals 93, m greater than or equal to 5, m minus minus, see out m times m, n. Seems to be a mistake with this one. What seems to be the mistake with this one? Either m is defined somewhere up above, or I should have the word int right there in front of the m. One or the other. Let's sneak an int in right there. All right, so again, to write this as a while loop, I would need to start by initializing my variable. Then I would need the while, m greater than or equal to 5, curly bracket. You can't see what I'm writing because I got too low. Thank you. See out. M. N times M. Anyway. Nothing changed there. I wrote the exact same command down. And then what? I need to increment my variable, m minus minus. So again, I said at the beginning of class, anything you can do with a for loop, you can do with a while loop, and anything you can do with a while loop, you can do with a for loop. They are interchangeable. It's just a matter of convenience. Which one do you prefer? Again, for something like this, where I know exactly how many times I want that to run, I would most likely use a for loop. I think it's easier to have all of the information right in the beginning. What would be different about writing this as a do while loop? Anything? Say that again. Okay. All right, so let's do it. What would we write? I guess I need to start with an int k. Do. What am I going to do? We do need the number, don't we? So we do need to initialize the k. Do. And then we would see out k and a space and 3 times k and then an end line. What comes next? While k is less than or equal to 21. All right, so 2 mistakes. I need the semicolon, and I also need to increment my k. And again, that's the downside of using a do loop or a do while loop, is sometimes it's easy to forget to increment your thing within the loop itself. Where with the for loop, you can't forget it. It's part of the code right at the beginning. All right, last one here. Rewrite the following code segment using a for loop. Sum equals 0, count equals 1, while count is less than or equal to 1,000, sum equals sum plus count, count plus plus. All right, so what would we need to change to write this as a for loop? Well, we wouldn't need that line, would we? So instead of the while, we would have the word for, and we could increment it right there, or start it right there, initialize it right there. Semicolon, I remembered this time, I didn't put a comma. Our test comes next, count less than or equal to 1,000. Count plus plus. Yeah, I'm not going to need this, am I? What do I need to fit inside my for loop? So I still need the sum equals 0. I still need to initialize that one. Well, count wasn't declared here, so I'm going to assume somewhere up above in this program there was an int count and an int sum. Because they're not declared here either. They're just initialized. So I'm assuming they're declared somewhere else above. What do I need inside my for loop? Sum equals sum plus count. And I think that's it. I don't need any curly brackets because I only need one line. I don't need to increment my variable because it's already incremented. So again, I think that when you're using something and you know exactly how many you want, I think the for loop is cleaner, less code to have to write. Questions about that?
Would a for loop be more efficient than a while loop because it's less time? Or not really?
Oh, that's an excellent question that I don't think I know the answer to. Which one would be more code efficient? I guess, if I were going to guess, I would guess the for loop is probably slightly more code efficient because we're able to eliminate 2 lines. But I don't know for sure. I would need something that would actually clock a program and see which one runs faster. Yes, they do make programs that actually do that. They make programs that clock how fast your program runs. Yes. And the reason I know that, my son is a computer science major at the University of Buffalo. When he submits his code, he doesn't print it off and give it to the teacher like you guys do. He sends it to something like a Turnitin.com like you do for your English papers. And it checks, one, that the code isn't copied. It actually, like Turnitin.com does, it checks to make sure that this code wasn't copied and pasted from somebody else's code. 2, it makes sure the code actually runs. And 3, it clocks it. Says how efficient the code is, how quickly it runs. A large portion of his grade is based on how efficient his code is and how quickly it runs. But again, as a computer science major, he's a junior now. I mean, he's writing programs that are thousands of lines long, and he's reading in massive data files. And so it's very important for his program to run efficiently. Where ours, most of what we do, what's the longest program you've written so far? Probably the states one. And that one was really just because you had to test 50 different states.
Writing programs with graphic user interface or just writing for
It depends on the course. He uses several different programming languages. Their introductory programming language, they don't use C, they use Java. So he learned in Java first, which they're very, very similar. But I think for some of his data structures programs, he's using graphic interfacing software. I don't know what software he's using exactly for that. So anyway, I know there are programs that will tell you how efficient your program is. They will test the clock speed. All right, well, I think we're about out of time. We'll start here on Thursday.